Welcome back. We're now ready to define the arcsine function. The arcsine function is the inverse of the function g theta equals sine theta for theta in minus pi on 2 pi on 2. I like to use theta. So this Greek letter, sorry, can't see the yellow. So this Greek letter is theta, and it will always stand for angle. So I like to use it because it reminds you that sine takes an angle out of it. And you'll see later on how it becomes useful when you have sine and arcsine to have one of the variables theta. That way you know which one is the angle and which one is just like the x or y value. All right, so now that we've defined it as an inverse function, we will be able to find a graph for it. So let me remind you of the graph of sine that we're looking at. So this is sine of x for x in minus pi on 2 pi on 2. This point here is minus pi on 2 minus 1. This one is 0, 0. This one is pi on 2, 1. And so when I flip it, I'm going to switch the x and the y component. So I'm going to get 1, a bit higher. I'm going to get 1 and pi on 2. I'm going to get 0, 0. And I'm going to get minus 1 minus pi on 2. And so I'm getting something like this. So this will be y equals arc sine, oops, I forgot the c, arc sine of x. All right, we have the graph. We can talk about the domain and the range. The domain would be the set of all x values that we're using. So here it would be this part, all the x values. So this one is minus 1, this one is 1. Notice that that's going to correspond to the range of sine like we saw before. So the domain of arcsine is minus 1 to 1. And then the range will be the set of y values. So from here to here, let me label these. This is minus pi on 2, and this is pi on 2. So the range of arcsine is minus pi on 2 to pi on 2. In fact, that's the angle that we started with here. We chose to restrict sine to this interval, and so that's going to be our range. From the definition and what we have learned in section 1.1, we now know how to evaluate this function. We know more than its domain and its range. So arcsine of x is theta exactly when. So that's the same thing I did for each inverse function. If I want to evaluate it, all I have to do is kind of send it to the other side and it becomes its inverse function. So x equals sine of theta. Oh, sorry, I'm not sure how I did this. All right, so you get that x is sine theta, and then you also get an extra condition that comes from the fact that we restricted our angles to lie between minus pi on 2 and pi on 2. So you're only allowed to have angles between minus pi on 2 and pi on 2. All right, so let me make sure, I've used some notation I didn't notice when I wrote it. This E, if I ever write it, that's going to mean in. All right, so I'll go in and change the notes. So it's probably not in your notes anymore unless I forgot. I'm going to change it in your notes, but if I write it, it comes naturally to me. I try to stop. It just means in. So theta in this set of minus pi on 2 to pi on 2. So this would be in the same exact thing right here. All right, so note that when we ask you for arcsine of x, we are giving you the sine value x. So we're giving you the value of sine. We're asking for the angle back. So it's like the opposite of what we usually do. In high school, we gave you the value of the angle. We said, what's sine of pi on 4? So we give you pi on 4, and you tell us that sine is 1 over root 2, or root 2 on 2. in this class, what we'll do is we'll give you root 2 on 2, and we're asking you, can you come up with an angle inside that interval whose sine value is this? Okay, so let's try some example. Oh, sorry. Corresponding to the angle, remember that the sine value corresponds in the trig circle to the y value. All right, so it's going to be the height on the trig circle. All right, so let's try a few examples. What about arc sine of 0? So if I ask you for arc sine of 0, I'm asking you to come up with an angle so that sine theta is 0. So sine theta is the y value. So here's my trig circle. I want sine theta to be 0. So that's the y value equals 0. And so I'm looking for the angle corresponding to this point. Notice that because I'm looking at minus pi on 2 to pi on 2, I'm only looking at this side. And so the only angle that would be in the right range would be 0. All right, so arc sine of theta is 0 because sine of 0 is 0 plus 0 is in the right interval. See? Didn't last long. All right. Now, if I ask you for arc sine of 1/2, then I'm giving you a different y value. So let me do it over here. I have my trig circle, which is a bit crooked. I have 1/2 right here. So y value is 1/2. So I'm looking at this angle here. If you remember your trig, you should know that sine of pi on 6 is 1/2. And since pi on 6 is in the correct interval, minus pi on 2 to pi on 2, then this would be pi on 6. So that's the angle in the right interval that would give you 1/2. All right, so let's do one more. Arc sine of -1. That's y value is -1. And so I'm looking for this angle right here. So that's minus pi on 2. So sine of minus pi on 2 is -1. And minus pi on 2 is in minus pi on 2 to pi on 2. It's in the right interval. And so this would be equal to minus pi on 2. All right, so this is what I expect you to do if you like trig and you're comfortable with it. If you're anxious and if you don't like evaluating trig and you're not that comfortable with the picture and the trig circle, that's not a problem. You have your calculator that will help, but I will also go through a method step by step right here, but that will be in a subsequent video.